another curved beam beams problem. I think if you haven't seen, I did the other one, the first one of which I think it's almost the same as this one, but I recommend that you start with the other problem if you haven't seen it. So a gantry is one of those machines. I don't know if you should call them machines or what, but they kind of look like this, and they have wheels, more of like cranes, and they have some maybe cable here, and they're used to load. They are big because a car maybe on its ratio is like this is a car. They're used to load containers on ships and all that. So yeah, they're just big poles that are moving around the harbor. They're like this, okay, whatever it is. So you can see this is just a small part of it. Kind of look like that. So okay, let's read. A country is constructed with whatever dimension is that as seen in the figure, and let us say if it is supported, it can support maximum of 20 kilonewtons. Okay, that's P. 20 kN. Determine the maximum distance. So do you want this guy to be safety applied, at which the maximum tension and compressive are given as this. So tension, we want it to be 30. Compression, we want to be 100. Okay, remember from the previous problem, I'm adding a load here. So this thing is, okay, let me trace over this guy so I can, okay, yeah, if I load this thing with the force P here, it will kind of do this. It will be, see, pushed like that. So let me say it like that. Look what happened. This guy went longer. That means this side was tensioned, this guy was compression. So we know now. What else they're asking for? How will a value change if the section was to be a circular area? Oh, okay, cool. So first you want to find the right distance. So this problem is the same as the other one, where you're trying to find stress in or out should equals to whatever the stress that is going on here because of just a load, plus stress due to it's a curved beam. Just call it like that. And this guy, we know him, that is mr minus r open close arc minus r close. Okay, and some of these variables I've talked about before. This is your moment, this is your r as in like neutral axis. This one is r, it's a point or a position of what you're interested in, and this guy is a centroid, and this guy again will be your neutral axis. Okay, and you have a formula to calculate that guy called neutral axis. It's area all over integral of dA all over r. But we want to find area is going to be this area, cross-sectional area 50 by 100, giving us something around like that. And then we put it there all over, and then here if we do this integral, our b, this thing looks like that. Our b is 50, lean bigger r from there to there is going to be 200, small r is given here to be 100. Our big R is from here to there, right? So we already know this from here to here is 100, and here to there is 100. So that's how I got 200. Then I'm going to punch this 500. all over 50 lane. I think that's just a 2, is it? Okay, so I'm getting 144.269. This is in mm's, right? Let me store that number at A. Okay, cool. Now we want to find our RC. RC is just a center, it's this guy, so it will be 150. It's just 100 plus half of 100, 150. What we don't have, we have, or we're trying to find the moment. Moment is going to be force by our force was given to be, what was it? Well, it's 20k, so it's going to be 20 times 10 power 3. Our R is the arm within the centroid. Remember, moment is calculated as centroid as an arm. So if I do that, what am I getting? So I'm obviously doing a mistake here, because I'm actually doing this mistake because the previous problem I had, my force was here, so I was using this guy. So in this case, we're trying to find D. That means we can't get M exactly, but you can get it as a function of P, right? So our R, the force is here, remember, so the moment around here is going to be whatever force is multiplied by D, right? Now we have M. This is what M is. So we have M, we have R. This is where we are interested in. We have area, we've literally everything here. Okay, let's start with inside. Inside is this guy. We said it was under compression, so we pick stress for compression. It was 100, so it's going to be 100 is equals to this guy is going to be force. What is force? 20 all over 20 by 10 power 3 all over area. Where is my area? 5,000, right? So that guy will cancel that guy. I should have just written 4, right? 4 plus M is 2 times 10. Let me keep this guy here. I outside. Okay, I'm writing M, right? And then that means I'll have a D here. R, what R is that one? Is this one. Neutral axis, of which is dot at A. Let me just minus, is the one that we're interested on. We haven't decided. All over area was 5,000. I think I should just write it as 5 times 10 power 3, so that I can easily see that looking the same as that one. R that we're interested in, we haven't decided. RC centroid, I think we decided to be 150. Not we decided, we calculated minus neutral axis, if we just dot at A. Cool. So technically we're going to change this guy. If we're interested in, we said inside is going to be compression. You pick 100 goes here. I'm putting 100 MPa because everything here has mm's, that means MPA's is cool. So technically you just put this thing on your calculator and expect your calculator to solve D for you. Let me say D if inside. Also you remember here to find this D, we're setting R is equals to inside 100. So let me go back to my calculator. So if I put this on my calculator, I'm getting 310.669 it's in mm's, right? So I'm going to do it again. I'm going to find D outer. Now my R, I'll set it on the very same equation, but now this guy will change, right? Or suppose this is a function of 2 parameters. Let me make this one a sigma, and so that I can write something proper. Di, now sigma is equals to 100 here, and what else I'm setting? I'm setting R 200. Good. For this one, D outer, I'm setting sigma into, what did I say? 80. Yes, tension. into 30 and I'm setting my R to 200. So let me make this look better. So this is our function. So we're setting in these two and then we're getting different answers, right? So now my answer is going to be 174.8027339. It's in mm also. Okay. Key notes that I actually made a mistake on while I was calculating. Remember this guy comes with a sign, right? Here it was compression. Remember this 4, it's a force, as in like the forces, that force is pushing it. It's under compression. We already made it positive. That means you already said compression is positive for this math, right? That means if I'm putting in here 100, its compression is positive, but if I'm putting in 30, it becomes negative. That's why I'm substituting 30 on the other side to yield out the correct answer. So these are the distances. I remember what the question wanted. What is a maximum distance? Okay. So technically the maximum is the smallest distance that we can get, because if we go to the bigger distance, that means this thing would have reached its maximum compression that it can take, or tension. For instance, let me just put numbers into it. Here it was compression. That means you needed to break or to fail in compression, you needed this much distance, but to fail in tension, you need this much distance. That means this thing will fail in tension first. That means this thing will probably break this side first as soon as it's at 174 mm. That means going above this thing would make this thing fail anyway. You can't even make it fail here by compression, if that makes sense. So thank you for watching.